Okay, so I thought I'd go back in time a little bit and share a presentation that I was doing like 9 years ago. Um, and a lot of it is on this idea of bringing control to projects. So a lot of what I was doing at the time was going to projects and finding them in various states. So they had challenges like no CI server, no code analysis, and that nothing was being triggered by their source control management system. Um, there were code reviews were not being conducted, and any issues were not tracked, and lots of issues were dropped. And on the automated builds and deployment side, they were doing manual deployments, no automated testing, no code analysis. Um, and then on the automated unit tests, there was very low coverage, not using a mocking framework, and that tests were failing and were being ignored and those types of things. So it was kind of like this situation where I was going in and saying there's a new and better way of doing things, which wasn't all that new, and it was a lot better. And people had seen this kind of go this story before and not succeed. So a lot of what I had to do was come up with ways to make it succeed. So I had this uh, basic philosophy, which is to divide these opportunities into quadrants and only focus on the lower right hand corner. Is that any new and better way of doing things had to be something that had high value and was of low complexity, low risk. So one of the sort of week zero things was to try and get some source control into place. And Team Foundation server, Subversion, Mercurial, Git, these were the things of the day, all right? So once we had that in place, it was the go to green strategy that I would do. It's basically 9 weeks to improve the situation. And the first thing I would focus on was a build script. So the idea is to write a build script using a common build scripting tool. And in the .NET environment, there are a couple, and we'll talk a little bit about this. But the idea is that this script would rebuild all. So the entire project solution, soup to nuts, would be rebuilt by one command file calling one script. And we'll talk a little bit about why this was so important. So the manual builds were being done by Visual Studio. And there's a lot of problems with trying to do manual builds from Visual Studio. But a lot of it is because the environments are different and you get a lot of variation. So this inconsistency. So Visual Studio is not a build tool. Let's just start right there. And so that inconsistency also created a lot of hero worship. There was one person who knew how to make Visual Studio build the software correctly, and that would create some success. So what I would focus on is this tool called MS Build. And if you know the Microsoft environment, you'll realize that the .NET framework has a build tool, and this build tool is what is actually used by Visual Studio to actually build things. And so if you write a build script in MS Build, it's first of all, it's conventional. It's part of .NET, so it's on every environment that has the .NET environment. It is used by Visual Studio and Team Foundation Server and these other things. Since it's widely used, there are lots of examples. And it succeeds. There's another tool called Nant at the time. And so you could build your build script with Nant. You could use PowerShell, which again, kind of builds on that. There are other make tools. You can automate many of the administrative tasks in Windows Server and Microsoft. There's a lot of MS Build extensions that allow you to automate, getting assembly information, doing XML peek and poke to transform configuration, copy files, zip them up, a number of different things like that. But sort of the no fluff message of week one is got to use MS Build. And what we would create is this one script that builds everything completely and consistently. And my slogan was run the runner. So we'd have this one file called runner.msbuild, and we'd have this one file called runner.bat. And when you ran the runner, it would do the things in the MS Build. This creates a virtuous discipline where the runner runs every build step from beginning to end in the proper order. It avoids a lot of integration hell because it can pull, rebuild, do all of the things. So people get into the pull, rebuild, code, rebuild, push, okay? And that is the basic discipline to avoid integration hell. When I would say 25 years ago, when I was a technical lead on a project, there were no integration servers. So what I would do every morning is I would pull, rebuild, and then send out information to the team and say, okay, you broke the build, you broke the build, you broke the build. And nothing happened until I could pull and rebuild without any problems. So that's sort of the go to green step one. Any questions or conversation at this point? Now, this is a key part of building onto the second step, right? Which is continuous integration. So now that you have one build, one tool that runs everything, the continuous integration is going to automate that, right? It's going to have a rebuild phase that basically runs that build script soup to nuts. The key thing is that whatever script is being run locally by the developers is the same thing that the continuous integration will do. It's the one script that runs it all. And so essentially creating, without a CI server, you can't know that you have this relationship, right, between Joe developer and Jane developer, right? So you've got each one firing and forgetting about the other. So the repository is going to essentially advise the whole team that there is an integration problem. And again, there are lurking quality issues if you don't get this under your belt. So basically week 2, install a CI server, get it triggered by a code push, and have it run the runner. TFS is one option. I don't think we're using that. Cruisecontrol.net was another option we'd use. Jenkins, there's an old favorite. And then there's something called TeamCity. TeamCity is a commercial product, but it is free. The professional version is free for commercial use, as long as it doesn't exceed certain parameters that it won't let you exceed. For example, you can only have 3 build agents. You can only create up to 100 projects. You can have an unlimited number of people using that team server. So one of the things that I would do is I would get team server and install it either on my machine or on some environment, so that the team would actually start using this this product. I don't know if you're familiar with the other JetBrains products, but there's something called WebStorm. I think that's commonly used. But JetBrains is the maker of TeamCity. It's a great way to introduce what I call an idealized build pipeline. It's much more straightforward than Jenkins, and it's very powerful. And you can sort of have the development team figure out what is the idealized pipeline, and then go back to infrastructure and say, okay, this is what we want our Jenkins pipeline to look like, and that type of thing. So the no fluff solution is get TeamCity and get the team working with it. A big part of week 2 is to start focusing on observe and report here. What's happening with the code pushes, what's happening with the build success, what is the build history, create feedback on the build, what's the personal process, try and establish some stakeholder visibility. So for example, if somebody is not running the runner before they do the push, then they're breaking the build. So you really need to go to that person who's breaking the build and say, hey, stop breaking the build. So you start creating this relationship between the CI server is making your bad pushes visible to everybody else. So that was go to green step 2. Any questions on that? Any thoughts or comments? Are you still there?
Still here.
The next thing is code analysis, week 3. So we're going to run code analysis tool against the code base. We're going to try and understand the inspections that are in that code analysis tool. So we're going to focus on the minimum, recommended, find one rule that's being violated, decide that one is worth fixing, and find maybe one that's worth monitoring, right? To really say, okay, this one is worth fixing, we're going to go fix it. This one, we need to keep an eye on it. And just focus on the one. The build script has to be enhanced. We need the code analysis running from within that build script. Again, that's the same build script that runs on every developer's machine, and it's the same build script that runs in CI. So we need code analysis to run locally, and we need it to run on the CI server. So, and also that if there is a violation, it breaks the build. So the build is only going to break when that one inspection rule is actually violated. So we just start with the one. So when there's no code analysis, we're in a danger zone, right? The danger zone is critical errors exist in the code and people don't know where they are. So what we're doing is we're uncovering critical errors, right? And we're trying to find coding practices that need to be improved. If we're not doing code analysis and that's not visible, then there are bad coding practices that are happening and nobody's doing anything about it. So that needs to stop. So in .NET, static code analysis is very well understood, very well described. It's been around for as long as the .NET framework has been around. So these identifying analysis tools isn't hard. There's one called FXCOP, which is called the framework. It's the framework COP. There's lots of books on the .NET framework guidelines and how to follow them. There's a lot of information here. It's an integral part of the .NET environment. There are stuff that's open source like Gendarme, again, another .NET tool. finds very common problems. There's something called style cop. It's integrated into Visual Studio, but it basically shows you styling errors, right? Helps enforce coding standards and the like. There's a tool called NDepend. NDepend goes deep in analysis in depth on design, cohesion, all of these types of things. It really tells you whether your code is structured architecturally well or poorly, and that type of thing. There are other tools like Simian is all about finding duplicate code. So you get duplicate code finders. And then you have Sonar, probably heard of Sonar Cube. Again, it's got a great dashboard. It basically consolidates all the rules, alerts. You can create thresholds. It's a must-have part of this. I try to get sort of the nth degree on static code analysis because it really is, to a large extent, free information. So the no fluff solution is really just to get FX comp into place, because this is the .NET framework guidelines, and we ought to be following those. And all the other things are great. They just need to, they needs to be championed and pushed. So at the end of week 3, we've created this virtuous cycle. We've added to the runner a analysis, right? So we're going to run this code analysis. This is a per commit analysis. So the CI server is going to run it. We're going to monitor it. We're going to look for violations that break the build. We can come up with more complicated nightly analysis to do more complete analysis and have reports on that. And we end up with this virtuous cycle where we're going to analyze, improve, monitor, analyze, improve, monitor, and go around and around on this over time. Okay. So that's Go to Green week 3. Thoughts, comments, questions? Okay. Week 4. So we want to write one automated unit test. That's all we do in week 4. Right? In the build script, we have the test runner within the build script. And of course, because it's the build script, we have the test runner within the CI server. So what we run when we run the runner on the dev side is the same thing we do on the CI side. Again, we have code analysis, and that's identifying, fixing, and monitor, but we're going to add in 2 inspections here, right? So last time we did only 1. Here we're going to add in 2. Okay, so since we have no automated tests, either unit or integration, we have to have conversations about what defines an automated test. Okay, so something that runs everywhere in every developer's machine is an automated test. And there should be no manual configuration, intervention. It should be deterministic, isolated, repeatable. If it doesn't fit into those guidelines, it's not really an automated test. Okay. So what we need to do in this week is select a testing framework, get to the point where we can run our one test with a scripting tool, and we can run the test within the CI server. That means add it to the runner. So what can we look at? We can look at MS Test. This is Microsoft's testing framework. It's so bad, I think they buried it years ago. It was really slow and really not helpful. There's something called MB Unit, which is very interesting, but I don't think it's really taken off. There's X Unit, which is very fast and is loved because of its speed, but it's not widely adopted. The one that's widely adopted is called NUnit. And this is free and open source and well integrated into Visual Studio. And so, we'll go with NUnit. Let's talk about mocking frameworks. The goal of them is allow for test isolation, and it enables interaction testing. So we're going to want to do that. So we introduce one of these Rhino mocks, been around for a long time. It has some nice features. MockQ is probably the leader, the most widely adopted, I should say. And so the no fluff solution here is NUnit plus MockQ.
That's what we got.
Exactly. And this is what we are seeking, is the big green check mark. So we add this to the runner.ms build so that it runs all unit tests. Per commit on the CI server, it runs all unit tests. And we're going to monitor that a failing unit test breaks the build. And on a nightly basis, we're going to run all the automated integration tests. So we have to tease apart what is a unit test and what is an integration test. And we got to figure that out on week 4. And we got to all be on the same page. And that's what happens on week 4. Get that done. We get a green circle instead of a dodecagon. Then we're on to code coverage. So our automated unit tests is we're going to have a very simple threshold. We're going to have one automated unit test per assembly, okay? And we're going to try and get one test class for each class under test so that we achieve 100% class coverage. And we're going to use our mocking framework, and we're going to make sure that all the unit tests run on the CI server. And the code analysis, we're going to identify, fix, and monitor 4 more code analysis violations. Okay. So code coverage, more tests, more analysis. So our coverage tool, we got to think about Visual Studio and running with the CI server. NCover is a great tool. OpenCover is an open source version, so NCover costs money. There's .cover, which is another JetBrains product, costs money. I find that the .cover solution is sort of the no fluff solution. Today, I don't know what Visual Studio would work best, but .cover works nicely. So the reason Visual Studio is important is because we want to see what code is not covered by our tests. The reason it needs to be in the builder is because the runner is because we need to break the build when our coverage goals are not being met. So 100% class coverage, we're going to have, as I described before, for every, we're going to have one test class for every class under test. We're going to use our mocking framework. CI is going to make sure that all the unit tests run. And we're going to have the build break if our class coverage is not 100%.
I have a question here.
Yeah.
How can we ensure that our class coverage is meaningful coverage?
At this point, we don't. What we're
Okay.
doing is we're dealing with the mechanics of making sure that every class is testable. So when I first work with a team, they've written a lot of classes, and those classes are not testable classes, or 95% of them can be tested, right? And then we usually have a debate about whether a test needs to be tested or not tested. And then we start talking about, well, is there any part of this class that we would want to test? And I rarely find a situation where somebody says, yeah, we've written this code, but we don't think it needs to be tested.
Right.
right? So this class exists, but it doesn't really need to be tested. Because the first question is, well, why do we have the class? Like, why wouldn't we just delete it?
Exactly.
So those are usually the conversations I'm having with people. So some people will say, well, we shouldn't measure something unless it's meaningful. And I would say, well, the only meaning it has is to know if we have class worth testing. So if you tell me 100% of our classes are worth testing, then we'll write an automated test against those. And then we'll know that we've covered 100% of those. So that's the
Right.
entire meaning of this exercise.
Okay. Yeah, I guess like I'm wondering like, because I could write a test for a class that does nothing, right? Just to
Correct. And that's
you
what
know.
we're going to do is
Okay.
we're going to write a test that does nothing. And then I'm going to look at it and say, is there anything in this class worth testing? And they're going to say
Gotcha.
yes. And I'm going to say, well, why didn't you write the test against that? And they'll
Okay.
be like, okay, I didn't know how. Okay, now we'll learn how. So that's why it takes a week. It's
Understood.
because either people come back with very, let's say, tedious arguments about these things, or we actually find something useful to do. But it's sometimes a little bit circular at this point, but that's what bringing better practices is all about. And I've been convinced at points to say, hey, this class is really not worth testing. And I'll say, okay, then let's mark it as not participating in our code coverage and say, you know, that class is actually not worth testing. It's pretty rare. It's usually because it's like a bridge or an adapter or something like that, where there's really no code in it. It just like, you know, A calls A prime.
Gotcha. Cool.
Again, we need to start talking about some of the more, let's say, controversial topics like code review. So in this week, we are going to introduce the topic of code review. We're going to add more tests. We're going to do more analysis. So we talk about code review strategies, and let's decide on one, right? So do we perform and then we perform a model code review, get together and talk about how that works, hash it out, define an approach that the team is willing to commit to, in that type of thing. On the automated unit testing side, we're going to write one unit test for each method in each class under test. We're going to try to achieve 100% method coverage. This becomes a lot more thorny because it's easier to find methods not worth testing than it is to find classes worth testing. And then we have a conversation on, you know, why is this method not worth testing? If it has any non-trivial amount of logic, it's probably worth testing. And it's probably worth identifying one thing you would test about it. Again, code analysis. Here we're going to identify and fix and monitor 8 more code analysis violations. And I sometimes get asked was, why are we defining 8 more? And I will say, because it's twice as many as 4. And that's what we did last week. And they'll say, well, that's arbitrary. And I'm like, give me another number. And they will say, well, I think we found 9. And I'll be like, 9 it is. So it's really about just putting a number out there to provoke a conversation. I have strong opinions loosely held, and it's kind of interesting how it gets these conversations going, and then I completely fold and people are like, wow, that was easy. So in week 5, we need to pick an approach to how we're going to do code reviews. The point of code reviews is to share opinions and track issues. So pairing is one way. Share opinions, track issues. We can do a group review, right? We can share opinions, track issues. We can do peer reviews, which is typically what people do today. Sort of the no fluff is the peer review. So how do we track issues? We typically track issues by comments that are made when people do the review, and we see that they get closed. Who owns this? It's the person who put up the pull request. They are responsible for determining whether the information is worth it or is not worth it. Okay. So we keep that ownership. Okay. So at the end of week 6, we've got code review happening. We've decided on this code review strategy. We've performed a model code review, so everybody knows what good code reviewing looks like. We may adopt multiple methods. We might decide that a group code review is necessary when there's an architecture or design change of a certain level of significance. We hash it out, we define the approach, and the team is willing to commit to follow that. On the automated testing side, we've written one unit test for each method. So we've got basically 100% method coverage ideally, and we are doing more analysis. And that's the end of week 6. Oh, by the way, I want to make it very clear. This is not COVID safe. We would have to have a socially, we'd have to have a socially distant.
You could put a plexiglass panel like in between.
Exactly.
I want that chair just as a joke for when people come in for interviews.
Exactly.
Make them sit in that chair and they have to decide which seat to sit in.
Exactly. So the next thing we're going to do as week 7 is packaging. Of course, we're going to do more tests, more coverage, and more analysis. So here we make sure that code reviews are happening. We are going to write more unit tests, and we're going to try and exceed a 40% statement coverage goal. So 40% of the statements, and I get this argument all the time. Somebody say, well, why 40%? And I will say, of the code that you've written, how much of it is worth testing? And they would say, I don't know. And I would say, well, why don't we just start with 40% is worth testing? And they'd say, okay. And so let's test that code. So it just becomes really more of a general goal that it's hard to define, but it's generally achievable. 40% of the code is generally worth testing and can be tested in a fairly straightforward manner. And again, code analysis, we're going to identify, fix, and monitor 16 more code analysis violations. So packaging and deployment is what we're all about. There's the classic MSI, which basically is a fancy way of using MS Build and zip together. It's more complicated than that, but it's basically a way to package something up into one file. There are web deploy techniques, but the idea is we're going to package something up and create a one thing. There's a tool called Octopus out there, which is great at packaging things up. Zip archives, it just works. Everything puts into a file structure, and then you zip it up, and that is your package. So the no fluff solution is just to zip archive things, and with MS Build, that's really easy to do.
And that's how AWS Lambda does it. So,
yep, it is the way to do it. So automated deployment, right? So we're going to write a deployment packaging script, and we'll talk about that. We can talk about that more in depth. But the idea is that you package something once and deploy many, and that you have one script that creates that whole process, right? So it it is parameterized, or it has environment variables, or it has, inputs, but in the final analysis, the same methodology is used everywhere. In your code review, you're going to make sure that code review happens. Again, it's really about supervising that. Automated test, we're going to try, and by this point, as a result, we have exceeded hopefully 40% statement coverage. And we're going to have our code analysis in place. So that's week 7. So week 8, we're doing the automated deployment. We automate the deployment for an integration environment as a per commit deployment. So that's what we're actually going to do in week 8. We define this integration environment, call it dev, call it QA, whatever we're going to call it. But as part of the per commit pipeline, when something is pushed, that it gets deployed there. Again, we're going to perform all the code reviews that we need to be performing. We're going to write more unit tests. Here, we're going to try to exceed a 60% statement coverage. And in code analysis, we're going to identify, fix, and monitor 32 more code analysis violations, right? So basically, things are getting fixed. What I find at this point is teams are coming to me and going, I think we've identified 78 code analysis violations we want to fix. And I will say, go to it, right? Like if they think they can get it done. There is a number of scripting tools that will allow us to deploy to that integration environment. MS Build is the no fluff choice here. At the end of our week 8, we've taken our packaging from week 7 and we've created automated deployments. And it happens as long as the continuous integration happens, it will get continuously deployed to that integration environment. There's no stopping it unless it is a code analysis violation or unit test failure. It's just what happens. So that's the end of week 8. So week 9, we have goals, and those goals are write more unit tests, or write more automated integration tests, try to exceed 90% statement coverage, or 80%, sorry. So here we're going to have to get more into how to use NUnit and MockU together. That's really a big part of this level. Our 80% coverage is really going to be a big part of defining sort of a minimum threshold. Usually it's quite straightforward to find 80% of the code is worth testing. And everything from here gets hard, and that's where teams struggle. But if you get to this point, you pretty much know that testability is a part of the architecture you want to tackle. Okay. So the overall results from where we started 9 weeks ago is now we have a continuous integration server. In that continuous integration server, we're doing code analysis, and it's triggered by a code push. Code reviews are being conducted regularly. What issues they find are being tracked and resolved. Code comments or modern tools like GitHub has make that very straightforward. In the old days, we actually had to find a way to track these things either in a spreadsheet or some other thing. Automated unit testing, we're up to 80% code coverage. Passing tests are a priority. It is essentially, you're not going to get your code into the integration environment unless all the tests are passing. So when tests aren't passing, everybody stops what they're doing to go fix the test. So fixing failing tests is a priority. The automated builds and deployments are happening. You know that when you do an automated deployment, that it's been tested and that code analysis has been done. Any long running tests are happening on a nightly basis. So you come in the morning and you hear about integration problems there as well. So congratulations, you are now at a new level of code quality.
What game is that from? What is this from? It looks so familiar.
Circa 2012, my children were playing it.
Oh
So-
wait, is that the cat game where the cats grow? I see a cat. I think it's a cat.
Yeah, well, let's not go on that. So at this point, focus on a retrospective. What did we like? What did we learn? What held us back? What did we wish we had? We'll do a presentation to the stakeholders. We've gathered metrics along the way. We've gathered some success stories. We can demonstrate the CI server and we present the results. And that is the go to green process.